Hi, so this video is meant to help you do the math behind finding the specific heat of a substance using calorimetry. So first, just a reminder of what calorimetry is, because this is important to solving the question, is generally we're going to take some material like a hot metal, and we're going to take that metal and put it into some cool water that's inside a calorimeter so we're not losing heat to the environment, and then using a thermometer, we'll measure the temperature change of the water as the temperature of the water goes up and the temperature of the metal goes down. And remember, the reason the temperature of the water is going up is because it's gaining heat from the metal. Okay, so the metal's losing energy, which is why its temperature is going down. The water's gaining energy, which is why it's going up. But since the metal's inside the water, all of the heat from the metal is going into the water. And that's going to be important to solve that for later. So let's look at example question and solve this. We're only going to do one question in this video. All right. So if 135.2 grams of a metal, so I'm going to go ahead and write those numbers up here. 135, not 132. So we take 135.2 grams of the metal at 98 degrees Celsius. So it's hot, right? 98.4 degrees Celsius. Is placed into the calorimeter containing 200 grams of water. Or sorry, 250. Wow, I can read my own writing. 250 grams of water at 19.5 degrees Celsius. I got that right first time this time. Okay. And then when the temperature changes, the temperature of the water went up to 21.8 degrees Celsius. And something to remember is that the metal has the same temperature. Because of thermal equilibrium, that's when the temperature stops. That's when they stop, theoretically, exchanging energy. That changes the temperature. Okay? So both temperatures are the 21.8 degrees Celsius when you're done. So when we solve this, the whole idea is it is very easy for us to find the heat that the water absorbed, but difficult for us to find the heat that the metal released. So we're going to use the easier calculation, and the first thing we're going to do is we're going to find out how much heat the water gained using Q equals MCAT. Okay, so again, I'm going to solve for Q. This is just like in the last video, where hopefully you learned how to solve for Q for water. So the mass of the water is 250 grams. Okay, and again, notice I'm focusing on the water for this. The change in temperature of the water is, let's see, it started at 21.8. It went down, it went up from 19.5 to 21.8. So technically, the water went up by 2.3 degrees Celsius. I subtract those two numbers. And then the specific heat. This is where people always forget. Remember, the specific heat of water doesn't change. It's 4.184 joules per gram per degree Celsius. That is a number you probably should remember because it's used a lot in these kind of questions. So I'm going to use Q equals MCAT. Mass of the water is 250 grams. Specific heat of the water is 4.184 joules per gram per degree Celsius. And the change in temperature for the water is 2.3 degrees Celsius. I plug that into my calculator, and I get 2,405.8 joules. That is the amount of heat that the water gained. And the water gained that from the metal. That is key right there, because the second step we're going to do is we're going to do the same idea, but this time we're going to find the specific heat. We're going to use the same formula, but we're going to do it for the metal. So now, instead of putting these information for the water, we're going to put it in for the metal. So easiest, I'm going to go back up here. My metals, the mass of the metal was 135.2 grams. The change in temperature of the metal, so this one's a little bit harder. Remember, the metal went from 98.4 degrees Celsius down to 21.8 degrees Celsius. So I'm just going to subtract those two numbers. To get negative 76.6, I'm sorry, to get 76.6. So technically, that should be a negative number. I technically should do 21.8 minus 98.4. I should do the final minus the initial, which will give me a negative number. But I don't worry about that because specific heats are always positive. And so unless you have a good reason for it, I would suggest you just ignore the positive negatives. Otherwise, you might end up with some strange answers. Okay, so that's my change in temperature. That's my mass. And then here's where people tend to make mistakes. This time, we're not solving for Q, we're solving for C. So how do I know what to put in for Q? Well, remember, the heat that the water gained came from the metal. So that means that the metal lost 2,405.8 joules of energy. It is the same heat. The water's gaining it from the metal. And that is a key statement right there. That's where a lot of people start to get confused and where they get lost. And so now it just basically becomes an algebra problem. There's lots of ways to solve this. I find that most of my students tend to like to just plug in the formula as is. So I'm going to write my Q equals mass times C. I'm going to go ahead and leave C as C because that's what I'm solving for, times the change in temperature. And then I solve for C. This essentially becomes an algebra problem. So when I do this, when I do my algebra for something like this, I know that I need to get rid of the 135.2, so I can divide both sides by 135.2. So I divide, and that'll get rid of that. And then I can divide the other piece because I want to get rid of the 76.6. Since it's multiplying times C, again, I'm going to divide by 76.6 because 76.6 divided by 76.6 is 1. Okay, and so in my calculator, I literally will just take 2,405.8 divided by 135.2 divided by 76.6, and I'm going to get my answer for C, which is, in this case, 0.232. There's more digits in my calculator, but I'm going to leave it like that as my answer. My units are joules per gram per degree Celsius because those are the units of specific heat, and since that's in joules, I should have joules on top. And so this is the answer for my specific heat of the metal. I hope this helps. I strongly suggest that when you're looking at this example, you actually do that calculation in your calculator. I find that some students will do the inverse of that. They'll divide backwards. They'll do some really odd things. If you have trouble, please come see me in class and I can problem solve with you, and I can fix that probably for you in 1 second when I see specifically what you are doing. I hope this helps. Good luck.